Today's lesson is about adding and subtracting radicals. And we talked before about what radicals are and how we can simplify those, so we'll want to kind of review that today and then kind of extend that idea to this adding and subtracting. So part A, let's start with just the adding. If I have example number 1, that's 3 square roots of 7 plus 8 square roots of 7. You'll notice that both have square root of 7 on there, so they are like terms. I do treat them like that, so they need to have like terms, they need to have like square roots to be able to put them together. And so then I just add the numbers out front. If I have 3 square roots of 7 plus 8 square roots of 7, this acts almost like an x, and I do 3 plus 8, which is 11 square roots of 7. And that's it, that's my answer. Let's try another one. If I have 9 square roots of y plus the square root of y, I have 9 plus 1, which is 10 square roots of y. Again, I don't do anything to these. I don't try to multiply. I don't try to add them inside or combine them in any way. They stay just like they are, just like terms did, and we learned that a long time ago. Okay, well, what about subtracting? How would that be different? Example number 3, 5 square roots of 7 minus 6 square roots of 7. They are alike. They're like terms because they both have square roots of 7 on the end. If I do 5 minus 6, I get negative 1 or negative 1 square roots of 7. Remember, we can always drop the 1 or include it. I know some of you feel way more uncomfortable to include it, so if you need to do that, that's fine. Let's look at one more. 8 square roots of 3 minus 5 square roots of 3. We know that 8 minus 5 is 3, and so it's 3 square roots of 3. Please notice that in all of these, I'm not changing what's under the square root in any way when I add or subtract them. Part C for today, and this is a little bit more difficult kind, and that is to combine and simplify. So that's when these are just a little bit more complicated. You always have to simplify first to be able to do this. If there isn't any simplifying that you can do, then you just go ahead and combine. We'll look at that here in a second. Example number 5, negative 8 square roots of 3d plus 6 square roots of 2d plus 10 square roots of 3d. Okay, now, notice I have some 3d's and a 2d. These two are alike, this one is not. So let me start by combining these two. I have negative 8 plus 10, which is 2 square root of 3d, plus, and then just 6 square root of 2d. And that's where I stop. There's nothing else I can do to simplify. How about one like this? 12 square roots of 2 minus 4 square roots of 11. You should be noticing that nothing is alike here. Square root of 2 is not alike to square root of 11. So that is just our answer. 12 square root of 2 minus 4 square root of 11. Nothing changed. What if I had the square root of 12 plus the square root of 27? Now, at first glance, you're probably saying, this is just like number 6. There's nothing alike, so there's nothing that I can do. I can, though, because I can simplify these. So let me start by simplifying the 12. I have 4 times 3, and then the 4, I have 2 times 2. There's a pair here. This should be remembering stuff from yesterday. Since that's the pair, that goes on the outside. I have 2 square roots of 3. That goes on the inside. For 27, I can simplify that to 3 times 9, and 9 to 3 times 3. The 3 is part of a pair, and there's a 3 that's a single. I accidentally wrote that sign. That should be a plus for sure. Now that I've simplified both of these, they both have a square root of 3, so 2 plus 3 is 5 square roots of 3. And that's all there is to that one. We just have 2 more examples to look at. Number 8, if I have 3 square roots of 8 plus the square root of 45. Again, these are composite numbers. Now remember, composite means it's more than one thing being multiplied, so it's not a prime number. Let's simplify that 8 down to 4 times 2 and 2 times 2. The pair is, of course, 2. So this time when I write it on the outside, I would be writing the 2 on the outside, but I would be writing this 2 on the inside. There's already something on the inside, this 3. So now I have 3 times 2 from this pair. 3 times 2 is 6, square roots of 2. And then I need to simplify this 45, which is 9 times 5. And 3 times 3. 3 is the pair. So 3 goes on the outside. 5 goes on the inside. These two are not alike, so I cannot combine them. That one was really just a matter of simplifying. Our last example in this section is the square root of 32 minus the square root of 8. Let's go ahead and simplify each. 32 is 8 times 4. 8 is 2 times 4. And guys, I could simplify these 4s, but since I already see that they're a pair, I'm going to go ahead and take those out. Put 4 on the outside, 2 on the inside. I'm going to break down this 8 by doing 4 times 2 and 2 times 2. 2 is the pair on this one, so that one goes on the outside. This 2 goes on the inside. If I have 4 minus 2, I get 2 square roots of 2. And that's the end of that one. Your homework is another half sheet. Good luck, and let me know if you have questions.